Lindsay. I am Tessa's husband. Tessa Lindsay, or Miss Tessa, just got done showing you the video of how to make paper airplanes. One of the paper airplanes she showed you was the squid. The squid will be assisting me as I tell you about the aerodynamics of flight, namely the paper airplane flight. So first we're going to talk about thrust. Now, you learned about thrust a couple weeks ago, and I will talk a little bit about that now. So, as we know, well, first we need an airplane. So, let's make a nice, perfect airplane with a little jet engine. So, any jet engine, to make it go forward, needs to have thrust. So we're going to have a little flame coming out of the back end. Now this is high-class drawing, so make sure you take notes. As we know, Newton has a law of motion describing thrust. That would be the third law, states that for every action there's an equal and opposite reaction. Now that action would be throwing out the fuel and exhaust and heat out the back end of the aircraft. That's going this direction, which is going to make the aircraft want to go this direction, because it's pushing out an equal amount that's moving forward. Now, the aircraft has a lot more mass, which means that it's heavier than the thrust, so you need to throw a lot more fuel out at a higher velocity, and all sorts of scientific equations to make it go an equal amount forward. Because the first law of motion states that it wants to stay at rest or stay traveling forward unless something else acts upon it. In this case, the thing that's acting upon it would be wind resistance. So, you have a wall of wind here that the aircraft is pushing through. Now, to show you an example of it, we have the squid and we have our wind. Now, the squid plane is going to come up and push through the air a lot like that. You see how it crunches the paper there? That's it hitting the wind resistance. Wind resistance will slow down the aircraft. It'll make it push back on the airplane, so it needs more thrust, right here, more thrust to keep going forward. The faster it goes, the harder the air is, and the more it has to push to go faster. So you get decreasing results the faster it goes. So I'm going to go ahead and put this guy up here for now until I need him again. So, the thrust and the drag fight against each other. But that drag is actually, I'm going to put a mark here, so we talked about that one. That drag is actually what allows the aircraft to fly, kind of. So, let's get rid of our airplane. Let's go ahead and draw a wing. So, let's pick brown for the wing. So this is a typical wing shape. Now, Daniel Bernoulli had a theory on fluid mechanics. Now, the fluid mechanics is the same thing as air. Air, it acts as a fluid, just a very light fluid. So if you take your cup of water, you put it on the stove, and you get it really hot, it'll boil. And that water will turn into air. Both things started, the air started out as a fluid, the steam did. Same thing, just a little bit less dense. So you have your wing shape here, and you can imagine it being inside of a tube. Now this is your air above and your air below the wing. The wing is moving, let's go green. The wing is moving this way, and the air is standing still. But to the wing, the air could be moving. Either way, it's the same thing. Now, the air, as it's coming through this tube, so the Newton's first law of motion, an object at rest tends to stay at rest unless it's acted upon. the air above and below the wing on the aircraft is at rest. It doesn't want to move. And so it's making this air that's right by the wing move faster or slower depending on where it's at. So you notice that this is a straight line. Shortest distance between 2 points is a straight line. This point and this point is connected. It's a very short distance. The air on the bottom doesn't need to move. Now the air that hits right here is going to kind of bunch up, and it's going to have to go either above or below the wing. So if it goes above the wing, it goes all the way around and out the back. That's a lot longer to travel. So Daniel Bernoulli theorized that your energy in your system has to stay the same. So your air going from here to here has to stay the same amount of energy as here. Kind of confusing, big words. Ask your parents to explain. I'm sure they'll love to. Your potential energy right here turns into kinetic energy when it's going around the wing. So it goes faster. Because it goes faster, it becomes less dense. Just like the water in the cup, when it's boiling, becomes less dense and turns into steam. It becomes less dense and moves faster. Now it gets to the same amount of air at the end as what you had at the beginning. Because the air goes faster here, it becomes, there's less air there, and so the air below pushes up, trying to fill the partial vacuum up here, or the lower pressure air. And so the wing is being pulled up by the lower density air above it as it's being pushed up from the bottom. And this is happening as it's traveling through. To the wing, the air is moving. And that is producing lift. Because of the wing design here, like that, it creates lift using a process described by Daniel Bernoulli. Let's go with that. We already talked about drag. So, if we take this wing and divide it into multiple sections, and at each section we take a snapshot and look at what's happening, let's create a little diagram, a little box, because all science discussions require something like that. So, I have a box here. We have kinetic energy. Let's make kinetic energy purple and potential energy red. So, we have kinetic energy and we have potential energy. So your potential energy right here at the beginning is going to be much higher. So let's say that this is the very beginning of the picture. We have a lot of potential energy and just a little bit of kinetic energy. But as the wing moves forward, or as we look farther on into what's happening in the system, is our kinetic energy, or our potential energy, is turning into kinetic energy as it speeds up on the top of the wing. So we have less potential energy and more kinetic energy. And it keeps on converting as the farther we go back. So let's say like right here, we have starting to balance out a little bit more. So we have a little bit, about half and half. That's a really horrible check mark. Apologize. And then at the back, it's now almost all potential energy. And just a little bit of kinetic. So the way you can look at this, or think about it, is when your mom's doing laundry or dishes at home, chores. You have a huge pile of chores lined up there, like laundry stacked up to here. And as your mom's looking at it, she sees all the potential work needing to be done to get that laundry out of there and into your dressers. And she looks at it, and it's just irritating, and it's frustrating because it's not getting done. It's not doing itself, and you're not helping. Or you might be. It depends. I know my kids, it depends. So you have all the potential laundry to do here. And you start moving forward. And the mood is lifting as the laundry is being accomplished. So that potential laundry turns into accomplished laundry. And it's just a little bit to get started. And the more the laundry gets accomplished, the less potential laundry there is to do, and the more accomplished laundry is done. Until at the end, a week goes by, and you fill up the laundry again. And so there's more potential laundry to be done, and less actual laundry done. And it's that cycle. But the total amount of laundry in the drawers, or the total amount of laundry in the house, hasn't changed. The amount of energy in this system hasn't changed. Just, it's changed from clean to dirty, or from potential to kinetic. That transition is what allows the lift to act on the wing and to move it up. Now there's other forms of energy that also interact here. Like you have the impact of the wind on the wing with that kinetic energy, which releases some heat, and that heat will transition into the energy of inside the system of the wing. But that's more advanced topics and stuff that I really don't understand myself either. But that's the basics of aerodynamics. Probably a little bit more in depth than what you need, but always ask your parents for ask them questions that you have, and for them to explain it more. And I'm sure they'd be love to look it up with you and help you out with that. So, thank you.